morning friends. Yesterday we have discussed about projectile motion, then the time of flight, range of flight, height of flight, and then now we require scalar product and vector product. Addition of vector we have studied. Subtraction of vector we have studied. Equal vector, when multiplied by -1 it becomes negative vector, that is multiplication by scalar. Again we studied, but we did not come across so far multiplying vector by vector, and there is no way to divide vector by vector, but there are two products in case of vector. One we call it as scalar product and other one we call it as vector product. Very interesting concepts in vector calculus which are used to analyze the situations in kinematics or dynamics also. Vector is basically called as a carpenter in mathematics. This tool, if you study it carefully, the vector can convert any object into any other object by transforming certain operations. That details you will be studying in 12th standard when you come across the matrix. Here, two basic things we are going to study. One is a scalar product of the vector and another one is a vector product of the vector. Let us begin with scalar product. What is the meaning of scalar product? Scalar product of two vectors is a scalar whose magnitude is the product of their magnitude and cosine of smaller angle between them. Once again I repeat definition of scalar product. Scalar product of two vectors is a scalar whose magnitude is product of their magnitudes and cosine of smaller angle between them. Suppose A is a vector and B is also vector. Then their scalar product is written as A dot B. Here for scalar we are using A dot B. Their scalar product A dot B by definition is given by, when I am writing only A, meaning is magnitude of A, meaning is magnitude of B, and cos of theta, angle between them. It's a scalar, so there is no need of direction. From figure we can show it. This is one vector A, this is another vector B, this is angle between them, then the scalar product of A and B is equal to AB cos theta. Now even though we change the sequence also, this B in B dot A, the scalar product remains same, AB cos theta, and when we come across A dot B is equal to B dot A, we call it as scalar product is commutative. Already this concept we have studied. So one property we come across about this scalar product, it is a commutative. It is also associative. Now let us consider two vectors. Vector A is represented by AXI plus AYJ plus AZK. AX, AY and AZ are the coordinates of point P, X, Y and Z coordinates. Similarly, B is equal to BXI plus BYJ plus BZK. Now we want to find out A dot B for these two. A dot B for these two. A xi plus ay j plus az k dot. I am taking bx I by j plus bz k dot product. Simply I wrote A dot B. Now we will operate it one by one. Then there becomes AXI dot BXI BY J BZ K plus second term AYJ. Second term becomes AYJ dot BXI plus BYJ plus BZK. Second term is I, J, K are the unit vectors along X, Y and Z direction. Similarly, third one AZK is a dot BXI plus BYJ plus BZK. These are together. AXI we operated on complete B, AYJ we operated on complete B, and AZK we operated on complete B. Now one by one again, when we go further, these all terms, there are total 3 lines, but when we again operate it further, then A dot B, it becomes AXI dot BXI, first term. This is operated on this. Similarly, this will be operated on this. That becomes AXI dot BYJ plus AXI dot BZK. Third one is operated. 3 terms. Similar manner, there are 3 terms related to this one. BXI. AYJ dot BYJ plus AYJ dot BZK. Similar way, these many AZK dot BXI plus AZK dot BYJ plus AZK dot BZK. Now AXBX, this complete term will become as, which is equal to AXBX I dot I. AX is a number, BX is also number, therefore it becomes I dot I. Let us see later on what is I dot I, but now time being it is like this. Similar way, AX BY I dot J. Similarly, AX BZ I dot K. 3 terms. Next also we write it as AY BX, it becomes J dot I. Similarly, AY BY J dot J plus AY BZ J dot K. Arrows must be there on each because these are the unique vectors. Now we can write it in third case, that is AZ BX K dot I plus AZ BY K dot J plus AZ BZ K dot K. Now let us talk about what about I dot I. Let us study first I dot I. We know these are three coordinates. It is I, it is J, and it is K. This is x-axis, this is y-axis, this is z-axis. I and J angle is 90 degree, pi by 2. J and K angle is 90 degree. K and I angle is 90 degree. But I and again I angle is 0. So this is magnitude of I is 1, unit vector. Magnitude of another I, it is 1. Cos angle between them is 0. Therefore it becomes 1 into 1, which is equal to 1. I dot I is equal to 1. Similar manner, J dot J and K dot K is equal to 1, which is I dot I. So scalar product with vector itself is 1. In case of unit vector, scalar product of same unit vector with itself is 1. So I dot I, J dot J, K dot K is equal to 1. Now let us talk about I dot J. Magnitude of I is 1, magnitude of J is 1, but angle between them is pi by 2. Cos 90 is 0, therefore it becomes 1 into 0, which is equal to 0. I dot J is equal to 0 because angle between them is pi by 2. Similarly, J dot K and K dot I is equal to 0 because angle between them is pi by 2. We all know it's a commutative. So J dot I have changed the order. J dot I is equal to, J dot I is equal to, I am taking it as K dot J, which is equal to I dot K, which is finally equal to 0. So once again I say I dot I, J dot J, K dot K is equal to 1. But I dot J, J dot K, K dot I, J dot I, K dot J, and I dot K is equal to 0. If you see it in this one, all these terms, this is 0, this is 0, this is equal to 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 0. Finally, only these three terms will remain. In that case also, I dot I, J dot J, and K dot K is equal to 1. Therefore, we get it as I A dot B is equal to AX BX plus AY BY plus AZ BZ. So this is product of two vectors. A dot B is equal to AX BX, A1 BY, AZ BZ. It is the scalar product of three vectors. Thank you.